Hi everyone. We are going to continue today with our second lesson in the statistics chapter. This lesson focuses on two different types of data plots, stem plots and dot plots. Okay, so a stem plot, you may have also heard this referred to as a stem and leaf plot. That's what we're going to kind of talk about on this first page, and then we'll get to dot plots on the second page. So stem plots are just sort of a visual way to arrange data that gives you kind of a visual sense of what's happening. These are really similar in how they work to what's called a histogram, which we're going to learn about later in this chapter. But the benefit of using a plot like this is you maintain the original data. So I could still look back at this plot here and figure out what my original chemistry scores were, as opposed to like a bar graph where I might be able to get an estimate, but I can't actually find the original scores. Okay? And so what a stem plot does is it takes the numerical data and splits it at some digit that makes sense. So for example, in this plot here, this is again what's called a stem plot. These numbers here in blue, those are like the tens digit, and these numbers over here are the ones digit. So what you'll usually see here is something that looks like this. Okay, like a key. And so what this is saying is one of my chemistry test scores was a 34. Okay, it also means that I had another chemistry test score that was a 39. So what we did here is we really just divided the data up into groups of 10, right? These are all of my 30s, these are all my 40s, 50s, 60s, and so on. Okay, and this gives me a visual sense of how many students did I have score in the 80s and 90s. Okay, how many students did I have that really tanked this thing? So that's what a stem plot is good for. A couple other things we're going to talk about. The range, and I know we've mentioned this before, but range is just how far out does this data spread? And you find that by doing the difference between the highest and the lowest data point. So writing this in shorthand, it's the maximum minus the minimum. Okay, and so the minimum should always be at the very top of a stem plot. The maximum should always be at the very bottom. But I mean, there's lots of ways that I could give you the data and still ask you to find the range. And then outliers, I think you've heard of these before, but outliers are data points that are very far away, like separated from the rest of the data. Sometimes those outliers happen for, just all kinds of crazy reasons. Sometimes we want to really look at those outliers, and sometimes we sort of disregard them. Now, there is a mathematical criteria for deciding whether or not something should be considered an outlier. We're not going to get into that today. Today, we're just going to kind of visually, try to identify outliers. But like I said, eventually we're going to learn the math behind them too. So let's practice reading this stem plot. Like I said, this is a list of chemistry scores. So each one of these numbers over here represents like a student's score. Okay, and so this would be like a 62 and then also a 68. This would be a 70 and a 75 and another 75 and so on. So the range in the scores, remember the range is the maximum minus the minimum. So my maximum score here is 98 minus my minimum score, which is 34. Okay, and that's going to be 64 for my range. Okay, so my test scores span a range of 64 points. It says describe any gaps or clusters in the scores. And again, we're not being super mathematical here. We're just kind of trying to point to things. So, for example, I would say most students scored somewhere between, let's see, the 70 and 100. Like, so here's a cluster, right? These are all clustered together. So most students scored in that range. And then I would say, based on this data, the 34 and the 39 are outliers. Now, as a teacher looking at this data, when I see those outliers, okay, I want to figure out what the heck happened, right? This tells me that this score is unusual because there's a gap here, right? There's a gap in the 40s and 50s. These data points are pretty far separated from the rest of the class. And so I would probably look back at those individual students and say, what the heck happened? Is this normal for them? Are they students who typically struggle? Have they been absent a lot? So I can't say we're going to disregard those scores completely. We're still concerned about why did those scores come out so low. But if there's a reason for it that we can kind of explain away, that helps us make sense of the data a little bit better. Now, as far as figuring out how a quote unquote typical student did on this chemistry test, we may or may not consider these scores mathematically, especially if we know there's some sort of extenuating circumstance. It might make more sense to only analyze these scores if we know there's some sort of crazy something happening with these students, okay? So just to kind of keep that in mind, when we talk about outliers, sometimes outliers are statistically significant, sometimes they are not. Okay, what score was the most common? What do you see most often here? Well, I see a couple of 4s, a couple of 5s here, but I think I see 3 5s here. And since those are in the 7 row, I would say 75 is the most common. We had 3 students score a 75. We had several scores where 2 students scored that, but I think that one's the most. Okay, that's it for reading from a STEM plot. Let's talk about another type of plot, which is the dot plot. So a dot plot is a data display to show frequency. It shows you how often a data point shows up, okay? And in this example too, typically what I would do in class is I would survey everybody and I would say, how many siblings do you have? And we would make a dot plot. I'm going to just totally make up some data, okay? So we're going to just kind of play pretend here. But what a data plot does, or a dot plot does, is it starts with like a number line. And I'm going to just say, okay. Oh, and I should have a 0, because we may have only children that have 0 siblings. Okay, so then what I would do is I would look out to the class and I would say, raise your hand if you have 0 siblings. You are an only child. And let's suppose 2 students raise their hand. So what I'm going to do is put 2 X's above the 0 to represent those 2 students. Okay, how many students have 1 sibling? Okay, so maybe, 5 students raise their hand. It is helpful with the dot plot to try to keep these rows level because then you can get an accurate comparison. How does 1 compare with 0? How many students have 2 siblings? Let's do a whole bunch of these. We'll say 7 students have 2 siblings. How many students have 3 siblings? Okay, maybe just one of you raises your hand. And then maybe I have no students with 4 siblings and no students with 5 siblings. So I ask and nobody says, hey, I have 4 siblings. But then when I ask about 6 siblings, 1 student raises their hand. And so this would be a dot plot distribution of our class. This would show, how many siblings do students typically have. And again, we can look at clusters and gaps and outliers. I could say that this one student with 6 siblings is kind of an outlier. Mathematically, I don't know if that's far enough apart to really be considered to be an outlier, but definitely unusual for this class. That doesn't mean that their data doesn't matter, though. In this case, I would probably keep that data point in here because it, there's no extenuating circumstance or anything like that where I can kind of explain that data away. If I was talking about the typical distribution here, I would say it looks like most of our students have either 1 or 2 siblings. So families with 2 or 3 children are most common among the students that I surveyed. And again, I just totally made that data up. Okay, but I do typically see a lot of 1 and 2 sibling responses here. Okay, so that's the idea behind a dot plot, is that I can look at this now when I see this many X's above the 1. If I was going to write that data set out, this would be like I have a 0 and a 0, and then I have 5 copies of the 1. Now, obviously, it's not nearly as fun to write it that way. And then I have a bunch of 2s. I don't even remember how many 2s I did, but so on. You do need to be able to think about it this way, though, if I start asking you to do math with these numbers, right? If I ask you for the mean or the median, you need to understand that this is what's actually happening here, is it's a list of that many copies of that number. But dot plots typically aren't too hard for us to figure out or read. I think you guys got a handle on that. That's it. That's it for 1-2. This lesson shouldn't take you very long, so we're going to go ahead and tackle homework for 1-1 and 1-2 today. And if you have questions, I'm sure we'll go over them in class. All right, have a great day.